The fourth lesson in Chapter 7 is on reciprocal functions. Reciprocal functions are unrelated to what we've been taking in absolute value, but they do have an importance in their own right. All right? We're going to take a look by studying the simplest reciprocal, and that's the reciprocal of the function y is equal to x. The graph of y equals x is a line passing through the origin with a slope of 1. You've seen this countless times before, so I'm just going to quickly graph it here. All right, there's the line y equals x. The reciprocal of y equals x is y equals 1 over x. Right? The reciprocal is just that operation that you do when you divide fractions. You have to flip. Right? So here we've got y equals x over 1. The reciprocal of x over 1 is 1 over x. So let's take a look at compare these two functions. All right. Oh, let's just start at the left here. All right. Way out here, we've got an x value of negative 10. So here we got an x value of negative 10. The reciprocal of negative 10 is 1 divided by negative 10. Wow, that's a really interesting number. It's close, quite close to the x-axis. Let's skip a few. Let's go to negative 5. The reciprocal of negative 5 is 1 over negative 5. So here we've got an x value of negative 5, and its reciprocal is negative 1 over 5. Let's keep going. See, negative 3 has a reciprocal of 1 over negative 3. Right, so we're getting a little bit farther. Negative 2 has a reciprocal of 1 over negative 2, which is negative 1/2. So you can see here, my graph is starting really close to the x-axis and it's curving away. When you get to negative 1, we got the reciprocal of negative 1 is negative 1. Now the question is, it's curving away. What's going to happen? All right, is it going to cross? Is it just going to keep curving down? Let's take a look at a few points. The reciprocal of negative 1/2 is negative 2. So when we get x equals negative 1/2, we go down to negative 2. Right? Negative 1/5 has a reciprocal of negative 5. So negative 1/5, we go down to negative 5. Right? And so we get this curve happening. All right, and now notice there's a very special thing here. When x is equal to 0, the reciprocal of 0 would be 1 divided by 0. And we know that this is undefined. And so you get this action where the graph curves away from the axis and then keeps going really steeply. Right? This line where we have x equals 0 is called an asymptote. Our graph gets close to x equals 0, but it never actually crosses it. Now, on the other side, you can imagine what happens when x is equal to positive 1/5. So let's take a look here. We got x and 1 over x. Right, so let's go. Positive 1/5, we take the reciprocal and we get 5. Right, the reciprocal of 1/2 is 2. The reciprocal of 1 is 1. And the reciprocal of 2 is 1/2. The reciprocal of 3 is 1/3. All right, 5 is 1/5. And you see we get the same sort of curve happening. All right, so here is the original graph, y equals x. We get a nice straight line. Its reciprocal, we get this curved thing happening. All right, important things to notice. When my original graph crosses 0, we get a vertical asymptote. It's called. At x equals 0. All right. Other important points when the y value is 1, the reciprocal is also 1. When the reciprocal is -1, the original is -1. All right, and that's the process we're going to use to graph regular arbitrary reciprocal functions. We're going to graph the original, and then we're going to turn the zeros into asymptotes and sketch the points where the y value is +1 and -1. All right, let's see how this looks in practice. Example 14 says, consider f of x is equal to 3x minus 9. Determine its reciprocal function y equals 1 over f of x. Determine the equation of the vertical asymptote of the reciprocal function. Graph the function y equals f of x and its reciprocal function 1 over f of x. With and without technology, discuss the behavior of y equals 1 over f of x as it nears its asymptotes. All right. Hey, if the original function is f of x is equal to 3x minus 9, the reciprocal function is y equals 1 over 3x minus 9. Determine the equation of the vertical asymptote. Right? The vertical asymptote of a function comes from the non-permissible values. Right? So what value of x would make the denominator 0? Let's see, 3x minus 9 equals 0. We get 3x equals 9, and so we get x equals 3. That's going to be its vertical asymptote. All right, so that's something to remember. When you're talking about the vertical asymptote, all you're talking about is the non-permissible values. Right? That'll make your life a little easier. All right, now we're going to graph the function f of x and its reciprocal function y equals 1 over f of x with and without technology. I'm going to do it without technology first. First thing we should notice is that f of x equals 3x minus 9 is a line. It's got a slope of 3 and a y-intercept of -9. So let's see, there's -9. It's got a slope of 3 up, 1 over, 3 up, 1 over, 3 up, 1 over. Right. There's y equals 3x minus 9. Right. Next, we're going to draw the reciprocal of 3x minus 9. First thing I want you to do is notice where the x-intercept is, because that is the vertical asymptote. We use a dashed line to indicate the vertical asymptote in a rational function. Alright, so there's my vertical asymptote at x equals 3. Right. My graph of my reciprocal function is going to cross at those 2 points. That's great. And it gets close to the vertical asymptote and curves away towards the x-axis. Right, in the negative region, my graph is going to be negative, right, and it's going to curve away towards the x-axis. So those 2 branches are the graph of y equals 1 over 3x minus 9. Right, so to graph a reciprocal function, you graph the original function, the x-intercepts turn into vertical asymptotes, and the graphs cross each other when the y value is plus or minus 1. Right? Make sure you draw your graph curving and getting close to the asymptote and getting close to the x-axis in both directions.